Solve the inequality 5 minus 2x less than or equal to 1, where x is a real number. Now, we have a linear expression here. So, we solve this linear inequality like we solve a linear equation. We isolate the x term first of all. To isolate minus 2x, we just subtract 5 from both sides. So we get minus 2x less than or equal to 1 minus 5, which is minus 4. The next step is to divide both sides by minus 2. So we will get x here, and on the right hand side we have minus 4 over minus 2. So this is where things differ from solving a linear equation. If we divide or multiply both sides of this inequality by a negative number, we change the direction of this inequality. So less than or equal to becomes greater than or equal to. So we get x greater than or equal to 2. Now a simple example will explain why this inequality changes direction. We know that 1 is less than 2. If we multiply both sides of this inequality by minus 1, we get minus 1 on the left hand side, we get minus 2 on the right hand side. Or we could divide both sides by minus 1. Well, you see that minus 1 is obviously greater than minus 2. Of course, if we multiply both sides by a positive number, we don't change the direction of this inequality. If we multiply both sides by 3, we get 3 less than 6. So what does this solution here mean? It means that if we take any number x, any real number x that's greater than or equal to 2, then 5 minus 2x will be less than or equal to 1. For example, suppose we take x equals 2.1. 2.1 is clearly greater than 2. If we plug it in here, we get 5 minus 2 times 2.1. That's 5 minus 4.2, which is 0.8. And 0.8 is indeed less than 1. It's less than the right hand side, which is 1. So it does check out. We could also take x equal to 2. We have an equality as part of this inequality. So we have x equals 2. And if we plug x equals 2 in here, we get 5 minus 2 times 2. That's 5 minus 4, which is 1. And 1 is equal to the right hand side. So we can have equality as part of this inequality. In this example, we want to solve simultaneous inequalities. We want to solve the inequalities 2x minus 1 less than or equal to 0 and x plus 3 greater than 0, where x is a real number. So we can take each inequality separately. So if we add 1 to both sides of this, we get 2x less than or equal to 1. Dividing both sides by plus 2 gives x less than or equal to a half. If we solve this one here, we get x greater than minus 3. Now what we want to do is get the intersection of these two regions. The region x less than or equal to a half I have indicated on the number line in blue. So a half is included, so we include this point because it's x less than or equal to a half. What about the region x greater than minus 3? X greater than minus 3 I have shown in pink. So it's all numbers that are to the right of minus 3, but we do not include minus 3. So you just put a circle around minus 3 to show that minus 3 is excluded, because we want x to be strictly greater than minus 3. We don't have any equality here. Now you can see where the two regions overlap. This blue and pink region. I'll just shade it in green. And a half is included. So any point in this green region is less than or equal to a half, but also greater than minus 3. So we can combine these two inequalities into one inequality. We can write it like this. Minus 3, strictly less than x, less than or equal to a half. Solve the inequality 2x minus 1 over x plus 3 less than or equal to 0 for x an element of real numbers less the point minus 3, less this number. The reason that x cannot be minus 3 is that we can't divide by 0. If we plug in minus 3 for x, we will get division by 0. We will get 0 in the denominator. So if we think of this thing here as a function, well then it's defined for all real numbers except for the number minus 3. Now if we had an equation instead of an inequality, this would be straightforward enough to solve. We could multiply both sides by the denominator, multiply both sides by x plus 3, and we would get 2x minus 1 on the left hand side equals x plus 3 times 0, which is 0. So we just put x plus 3 times both sides of this equation. These would cancel out and we get 2x minus 1. 0 times anything is 0. So we just really be solving this equation here. We only have to just put the numerator equal to 0 essentially. And from this we get x equals a half. Now we do the same kind of thing when we're solving an inequality. However, there is a problem. And the problem is that x plus 3 could be positive or negative. If x plus 3 is positive, well, it won't affect the direction of this inequality. If we multiply both sides of an inequality by a positive quantity, this inequality remains the same. However, if we multiply both sides of our inequality by something negative, if x plus 3 is negative, then this inequality changes direction. So we have to look at two separate cases. The case where x plus 3 is positive and the case where x plus 3 is negative. X plus 3 cannot equal 0. So we have that, because if it did, we will have division by 0. This function is not defined for x equals minus 3. So let's start by taking case 1, where x plus 3 is positive. Now, if x plus 3 is positive, it means that x is greater than minus 3. We just rearrange this inequality. We multiply our original equality by x plus 3 to get rid of this denominator. So we get 2x minus 1 less than or equal to 0. So when you multiply both sides by a positive quantity, if x plus 3 is positive, it won't affect the direction of this inequality. So the less than symbol will remain. So I've multiplied both sides by x plus 3. And I get down to this. I can solve this inequality to get 2x less than or equal to 1, which means that x will be less than or equal to a half. So this is a solution when we multiply both sides by a positive x plus 3. But if x plus 3 is positive, it means that x must also be greater than minus 3. So we have to combine these two inequalities together. So this solution that we got here is constrained by this. So we must have that x is greater than minus 3 and x is less than or equal to a half. Now, in the last example, we covered this. We found that these two inequalities can be combined into minus 3 less than x less than or equal to a half. So this is one solution set of our inequality. Now we have to look to the second case, because when we got this inequality into a straight line, we could have multiplied both sides by a negative x plus 3. So we multiply both sides of our inequality by a negative quantity. These will cancel out, and this will change direction. Less than or equal to will become greater than or equal to. So we will end up with 2x minus 1 greater than or equal to 0 times x plus 3, which is 0. And this inequality is subject to the constraint that x plus 3 is negative. In other words, x is less than minus 3. Write that here. We solve this inequality here to get 2x greater than or equal to plus 1, which leads to x greater than or equal to a half. So this is the solution. This is a solution to our linear inequality. subject to this constraint. So we have to combine these two together. So we want values of x that are both less than minus 3 and greater than or equal to a half. Now you can see that there are actually no such values of x that simultaneously satisfy both of these. So there is no solution for this case. So in other words, if x plus 3 is less than 0, or if x is less than minus 3, then this inequality doesn't actually have a solution. So if we pick any number that's less than minus 3, like say minus 4, and plug it into this inequality, we will get something that's actually positive, that's actually greater than 0. You know, if you plug minus 4 in here, you get minus 8 minus 1, which is minus 9, divided by minus 4 plus 3, which is minus 1. So we have minus 9 divided by minus 1, which is plus 9, which is greater than 0. So there aren't any values of x that satisfy this inequality when x plus 3 is negative. So the only solution set to our problem is this one here. We could think of solving this inequality in a different way than from multiplying both sides by x plus 3, because we have 0 on the right hand side. And we want to find the values of x for which this fraction is less than or equal to 0. Now the only way that a fraction can be less than or equal to 0 is if, say, the numerator has one sign and the denominator has opposite sign. So the numerator could be negative and the denominator could be positive. Actually, for equality, to make this fraction equal to 0, the numerator could also equal 0. So we have a positive quantity on top, or 0. If 2x minus 1 is 0, then the whole thing is 0. But we have a negative quantity underneath, so a positive divided by a negative is a negative. That's what we want. So we could solve between these two, which we've already done actually. Or we could have this sense such that the numerator is negative or positive and the denominator is negative. Actually, for a negative numerator and positive denominator, we have this situation here. And the other way around, where we have a positive numerator and negative denominator, gives this situation here. But for equality, for equaling 0, we have to have that the numerator is equal to 0. And of course we can't have the denominator equal to 0, because if it was, we would have division by 0, which is undefined. So that's another way we could think about solving this inequality. That only happens when we have 0 on the right hand side. You can check your inequality by typing it in here. You will get a plot of the function 2x minus 1 over x plus 3. We want to see where this function is negative, where it's less than 0. So we can see, well, for this range, we have values of x less than 0.5. But we know that x has to be greater than minus 3, so only part of the graph is shown here. To get a better picture of this function, I've changed the range from x equals minus 10 to 4. Now, this type of function is called a rational function. I will be covering this in other videos, how to graph them. This blue line here is not the y-axis. This blue line is the vertical asymptote passing through x equals minus 3. The shaded region shows the values of x for which this function is less than or equal to 0. So less than or equal to 0 means where is it below the x-axis. So the values of x for which the curve is below the x-axis. Those values of x range from minus 3 up to this value here, which is plus a half. If you take values of x outside of that range, we see that the curve is above the x-axis. The value of the function at those values of x will be positive. So for values of x greater than a half, f of x is positive. Or for values of x less than minus 3, f of x is positive. This section is above the x-axis. never actually crosses this x-axis. So we could have solved this inequality by plotting the graph, and I will explain how to do that in other videos.